Hi, this video is about electron configuration. So the question we have here is to write momentum. So the keyword here is Fe2 ion. There are two concepts here. First, how to write a configuration for a normal or neutral atom. Second, how to write a configuration for an ion. So to write a configuration, you have to memorize a few things. The order of the orbitals. The way I memorize these is by thinking of them as a tall building. Well, this tall building have several levels, n equal 1, 2, 3, 4, etc. all the way until n equals 7. The n equal 1 also called the ground level. Alright, then on each of these levels, there are rooms called orbitals. These orbitals are called S, P, D, F, etc. The funny thing is, the number of rooms or orbitals equal the level number. So level 1 only have one room, which is called 1s. Level 2 has 2 rooms, 3 has 3. Now finally, in each room, there are beds called suborbitals. Each suborbital can hold 2 electrons. Now the number of suborbitals depends on the orbitals. So S have one suborbital, one bed. All the S have one bed. P has 3. D has 5. I had to make the house bigger because now F would have 7. Now the last thing you have to memorize, and you have to memorize this, is that electron fills the suborbitals in a funny way. So imagine you're having a fire hydrant in the bottom right corner here. It will start spraying the 1s orbital first, then the 2s, then 2p, 3s, then 3p, 4s, then 3d, 4p, 5s if 5s was here, and etc. this way. Okay? So the orders that electrons will fill this orbital will be 1s, 2s, 2p, 3s, 3p, and then instead of 3d, you will start on 4s after 3p, then 4p, etc. Now applying this concept to our questions, the question asks for Fe ion. So first we must look at the periodic table and find Fe, which have 26 proton. So for a neutral Fe atom, you will have 26 electrons. These electrons will fill in the orbital in the order that we have learned: 1s, 2s, 2p, 3s, 3p, etc. Remember that s orbital have one suborbital, so you can have, and one suborbital can have 2 electrons, so you can have 2 electrons in the s. The p have 3 beds. 3 multiplied by 2 is 6 electrons, and d have 5 beds, so you can have maximum 5 multiplied by 2, 10 electron. So let's see, we have 2 plus 2 plus 6 is 10, plus 2 plus 6 is 18. We have 26, so 26 minus 18 is 8. We have 8 more electron, so we can have 2, 8 minus 2, so there's 6 electron left. So we would say 6 electron in this d orbital. And there's no more electrons, so we can ignore this. So this would be a normal configuration for ion atom. Now, this is an ion with 2 plus, meaning that you lose 2 electrons. And a very common mistake is that people start to taking out electron out of the 3d orbital. That is incorrect. You will still be taking electron out of the outermost level in your electron configuration, and the outermost level here is the 4s. So you will take electron out of the 4th level, not the 3rd level. Very common mistake the student do is when they do ion for Fe, they take the 26 electron and minus 2 electron from that, so you have 24 electron, and they started to fill it up until here, and then 3d4. That's not correct. The ion would have no 4s level and 3d6.